This lesson is on solving quadratics using the quadratic formula. Now you may remember this from Algebra 1. Let's see if you do. The quadratic formula is x equal negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now this is the same a, b, and c as we find in the standard form of the quadratic equation, ax squared plus bx plus c is equal to 0. Now to solve, you're just going to identify a, b, and c and then substitute them into the formula. Pause now and write down everything on this slide. Now, why would we use the quadratic formula instead of factoring or maybe graphing? Well, the quadratic formula allows you to solve any, and I mean any, 100% of the quadratic equations that are out there, even if you can't factor it. So it definitely has its place and value. Please pause down and write down your version of this particular point. Now, an important piece of the quadratic formula is what's under the radical. That's the square root symbol we're talking about. The b squared minus 4 times a times c. This piece without the radical is called the discriminant. And the discriminant can tell you how many and what kinds of solutions you have. Please pause now and make sure that you have this documented in your notes. Now, why is the discriminant important? Well, the discriminant tells you the number and the types of answers or roots you will get. Now remember that roots is one of the 4 ways that we describe solutions. We call them solutions to quadratics, roots, zeros, or x-intercepts. So the discriminant tells you how many and the kinds of solutions you have. The discriminant can be positive, negative, or 0. It's going to be just a number. If you remember discriminant for matrices, you'll remember it was just a number. And this is the same idea, different formula. Pause now and copy everything on this slide. Now, what does the discriminant tell you? Well, if the discriminant is negative, then you have 2 imaginary solutions. Now, you may not know very much about imaginary numbers yet. We're going to learn about imaginary numbers in a few days, but for now, just note that it means you have 2 imaginary solutions or no real number solutions. If it's 0, you have 1 solution and it's a real number. If it's positive and it's a perfect square, then you have 2 solutions and they're real numbers and they're rational. And if it's positive but it's a non-perfect square, then you have 2 real solutions, but they are irrational numbers. Pause now and copy down everything in this table. You will be asked at various points on quizzes and tests to tell us how many and what type of solutions a particular quadratic has. Now let's take a look at an example. We're going to find the value of the discriminant and describe the nature of the roots for each quadratic equation in our examples. And then we're going to solve this equation using the quadratic formula. So an intermediate step would be finding the discriminant. All right, now these are the values of a, b, and c in the case of this particular trinomial. So a is 2, b is 7, c is negative 11. The discriminant is b squared minus 4 times a times c. So it's 7 squared minus 4 times 2 times negative 11. That gives us 49 plus 88. So our discriminant is 137. So it's positive, but it's not a perfect square. That means we have 2 solutions. They are real solutions, but they are irrational. Please pause now and write down this example. Now, in our next example, we're going to go ahead and solve that equation, that same equation, using the quadratic formula. And so, as we identified before, A is 2, B is 7, C is negative 11. Now, this is the quadratic formula. I do like to write it down so that I'm sure I'm doing my substitution correctly. And now I'm going to substitute A, B, and C in the appropriate places. And I'm finding that my answer is negative 7 plus or minus, because that's part of the formula, the square root of 137, whatever that is. Please, please, please do not take your calculators and take the square root of 137 and get some really big, long, complicated decimal. Just leave it as the square root of 37. That is accurate and mathematically correct. And that whole thing is divided by 2 times 2, which is 2 times A. And so this solution says we have an x-intercept at negative 7 plus the square root of 137 divided by 4. And we have a second x-intercept at negative 7 minus the square root of 137, all divided by 4. So there are two real solutions, and they are irrational. Pause now and copy down this example. Now let's look at a third example. We have 3x squared plus 5x plus 6 is equal to 0. So we're going to identify A, B, and C. I do want you, when you're solving using the quadratic formula, to write out A is equal, B is equal, and C is equal. In this case, A is 3, B is 5, and C is 6. So here's my quadratic formula, and I'm going to substitute in A, B, and C appropriately. Next, I'm going to reduce what's under the radical and reduce that fraction if I can. In this case, it's completely simplified. When I simplify what's under the radical, I get 25 minus 72. Well, 25 minus 72 gives me negative 47. But I have a problem here, because I really can't have a negative number under a square root. They are not part of the real number system. And so, if you refer back to the table that talked about the types of solutions you can have, one was if the discriminant was negative, and that's what we have here, a discriminant of negative 47, then I had two imaginary solutions, but I had no real solutions. And that's what I have here. I have no solutions in the real number system. However, I do have two imaginary solutions, and we will learn about imaginary numbers and how we can represent these kinds of solutions better in a couple of lessons. Pause now and write down this example. Now I want you to practice. I want you to try these 4 examples, and I've included an answer key. So on your own paper, try to get the right answer, and if you can, that's great, then you understand. If you cannot, then bring your work to class along with your questions. I look forward to seeing you then.